One of the most important skills in robotics and engineering is learning to see the difference between a solution that simply works and a solution that's truly robust for repetitive use.
Our outtake is pretty unique in the fact that this is a dead axle and this is a dead gear. And when this axon spins, it just spins our robot. It spins our arm around.
Okay. So you rotate around that dead gear as opposed to
having it rotate the...
Yeah, okay.
Yes.
This is what builds your engineering intuition, and it teaches you how to look at any design, including your own, and think critically about how to take a functional idea and make it more reliable under the pressures of a tournament. I'm Coach Pratt, and as a coach of national champion FC teams and a Benelux winning alliance captain, I can tell you that this ability to analyze and iterate is what consistently leads to success. So in this episode of FTC Robots Revealed, we're going to do exactly that with Team 9473 Crocobots from the USA. I'm going to walk you through the robot's interesting approaches, like the use of a linear rail elevator and unusual dead gear outtake arm, and even how they use cardboard for some game piece management. This robot is a great case study in how teams find ways to get the jobs done, and it offers valuable lessons for your own design process.
Tell me about your general strategy to this season. What's your approach?
So when we were building this one, we looked back at our state, our qualifier robot, and what we had was we just had one swinging arm around a big axle with some heavy-duty worm gearboxes that rotated around, and we found it inefficient to only use one thing. And so instead, what we decided to do was we decided to have two different things, and we would transfer it. And so we have this intake right here mechanism that flips out, that's able to grab. We power this through an axon that's belted towards active
Sorry,
axle.
You just totally went past there. That is, you're powering with an axon?
Yeah, this axon max servo.
Yep.
And then we have it belted towards this axle here.
Okay.
And it's able to spin our claw down into the field.
Is that GT2 timing belt then?
Yep, GT2 timing belt.
Yep. And what's this what is your strap here
the problem is we didn't have the right timing belts, so we had cut to length. And so we glued these together.
Yep.
And then they started slipping a little bit. So the easiest fix for us to tension it was we put a little zip tie on it to tighten it a little.
Okay.
Since it doesn't go the entire way, it's kind of like a makeshift and if it breaks, we have more cable ties.
Yeah, okay, that works. Yep.
And so this flips down. Both of our claws are open sourced from a different team called Leviathan Robotics.
Yep.
And so we just open and we have it directly attached to a servo.
Yep.
And so it's able to swivel to match the angle of the block. And then
do you have a servo block in there, or is it literally just it's just hard mounted onto your servo?
It's just hard mounted on.
Yeah, okay. Yep.
And then from there, we grab it and then we're able to bring it back in.
Mm-hmm.
And now to power it, we had done many different things. So we originally were going to use two axon maxes on both sides with two-piece linkages.
Yep.
However, we found it really hard to code them together.
Yes.
And then we also were questioning if the power was lacking because we couldn't get our hands on a power module for them. And so we switched to a motor, and then we got frustrated when our motor wasn't big enough. Right? Yep. And we got frustrated when our motor wasn't big enough. So we just put a heavy-duty
and actually
gearbox on it.
You can feel the heat. Yeah, that's pretty warm. Yeah,
it is. So,
so you got a worm gear on there then.
Yep, it's a worm gearbox underneath it.
Yeah, okay.
Yep. And so it's very overkill.
Yep.
However, our robot was already heavy.
Yep.
We plan on playing a little bit of defense, so it'll work for us as we're going.
Yep.
And then moving on to our outtake, we have
just a question on this intake. Can you show me how far it extends out and how far that linkage goes?
Yeah, so if we reset it real quick.
Yeah, if you want to start it up, that works great. I always like seeing these things in action.
So this is... Okay, that's wrong. So that wasn't supposed to happen.
Okay, we're going to try that one.
Okay.
Yeah, just one more time here. There we go. That's what it's supposed to do.
Okay.
And so when we code it, it's supposed to come right there.
Yep.
And then when we flip out, we just hit one button and then it flips out and we're right there. And so if I extend it all the way out for you.
Oh, that's why you have such a hard time pulling it back, because you actually almost basically over-center.
Yeah, because of the height limit, we almost have to pull it all the way down and all the way back.
Yep.
And so our motor is able to do it, but
that makes sense why you're using such a beefy motor now.
Yep.
Yeah.
And it still is overkill.
Yes.
However, we just got frustrated and we were like, slap the biggest thing on. It was the easiest fix.
Fair enough. Yep.
And then,
okay, so tell me about that transfer then. How do you get that transfer out to your outtake?
If we click it, we grab it and bring it back.
Mm-hmm.
And then we bring it forward.
Yep. And these are all single buttons to do that, right? And I imagine it's not supposed to grab that.
It's not. It got caught here.
Okay.
So
I think slip a tooth, maybe?
I think a tooth slipped on here, yeah.
Okay.
But basically, this faceplate is supposed to push the block forward since this is a looser grip. And then we are able then to grab a block.
Okay. Yeah.
And then moving up to the outtake, we just have simple go build a Viper slides here.
Mm-hmm.
We were looking into the, I don't remember what they're called, but they're the ones that are milled. Yeah,
Masumi. Yeah.
But those are like generally milled or like custom made. And since we didn't have access to that, we were like, okay, we have these Viper slides lying around. We might as well use them.
Mm-hmm.
And so we belted them because our first experience with string, they just kept snapping.
Oh, that didn't sound right.
Now, what did you press?
I pressed the one button. There was something hot out.
Anyways, that doesn't sound like anything's broken.
No, yeah, it sounds like your cardboard. You're just pressed a little bit there, but it looks like it held it in just fine.
Yeah, so this is getting switched out for polycarbonate anyways.
Yep.
And we're also still working on decoding.
Yep.
Yeah.
Understandably so.
Fine tweaks, but basically mounted on it is our MGN rail. We saw a couple teams using it. The ones that we specifically saw also used like a small little linkage.
Yes.
Move the rail side to side.
Yes.
But since we were basically at the vertical height limit, we decided we should probably just set it up kind of like a belt pulley.
And why do you want it to slide along your elevator?
The goal of that is when we were designing it, we wanted it to be super optimal. Yeah. And so we wanted it to go from one side to another.
Okay. Is that makes it easier for you to get out to a basket then, or makes it easier to do a sample transfer, or?
It's so in autonomous or in player op mode, we can grab samples and also place them in the basket without turning around.
Without having to rotate. Okay. Yeah.
Yep.
So rather than having a flip over claw, you decided just to slide the whole claw through.
Yep. And so the idea is while he's sliding it forwards and scoring it, I am able to reach in and grab another block. So we don't lose any efficiency waiting for one thing to finish to another. We can just keep going. And then our outtake is pretty unique in the fact that this is a dead axle and this is a dead gear. And when this axon spins, it just spins our robot. I mean, it spins our arm around.
Okay. So you rotate around that dead gear as opposed to
having it rotate the.
Yeah. Okay.
Yes.
Was that
basically
essentially
opposite
constraint issue or?
So we were thinking about mounting a motor here.
Yep.
Or like having this longer and having us belt the axon to this. But since we were having trouble belting, like our base movement and this here, we decided maybe it's probably easier if we went for something else, like just straight gears. And this allowed us to use double helical gears here. And so the advantage to those is they'll keep continuous contact since they're helical rather than spur gears. And then since they're double helical, they won't slip off of each other.
Yeah, herringbone is nice. It does look like you did grate a little bit on one of those, though.
Yeah, they definitely do.
Yeah.
And when that happens, we just kind of rotate to the next side. And so since we only use about half of it.
Yep.
So
and do you have a hanging mechanism or no?
Not currently. However, we plan on just putting just like a clip up here.
Yeah.
So that we just pull up to the last layer.
Yep.
We found watching different teams play that
should be enough to get just a second.
It doesn't really bother to go all three levels since unless you max out the rest of the game, it takes much longer to achieve those 15 points than say 2 more clips.
Yep. So tell me about your drivetrain. It's using a Strafer chassis. Do you have any odometry pods on here? Using an infrared sensor?
Yes.
Just the encoders run to?
We have 2 odometry pods, and we have a function in the code that
So
is it possible to turn the robot off and flip it on the bottom so we can see those autopods, or is it easily seen?
The easiest way is probably picking it up.
Yeah.
But so what we did was we used to be running purely with the encoders built in, and we very much didn't like those.
Okay.
And so instead, we went for the odometry pods and then the computer that calculates them.
Mhm. Oh, yeah, using a pinpoint.
Yeah, the pinpoint calculator.
Yeah, okay. Yeah, that's good.
Yeah, you're
Thank you.
good. You could set it down.
Sorry,
It's
it's
not on
heavy.
our thing.
Yeah.
Yeah, quite heavy.
What's your fishing line? Yeah.
Anyways.
Yep.
So we use that pinpoint calculator, and there's a lot of open source code out there to use those.
Yeah.
So for autonomous, we use Roadrunner, and they'll be able to plan our pass out for us using these. But then we also have used open code for our main drive. And so our left stick, whichever way we move the stick is where our robot moves. It's all pre-calculated. There's a lot of open source things that you can check out.
Yep.
And essentially, yeah.
Cool. And what are you most proud of on this robot?
What I'm most proud of? It's a good question. I would say what I'm most proud of is a lot of the time we haven't been able to get a transfer system to work. And because we haven't been able to, we've had to scrap the design and move to something that is a little easier, such as just a rotating Viper slide that goes around. But this time we got the transfer to work in a very, in my opinion, simple manner.
Yep.
And so it has helped us make a robot that has a lot less human interaction, need for human experience.
Cool. Awesome. Well, thank you for sharing, man. It's a great robot.
Thank you.